In our geotechnical report, we normally have a section for frost susceptibility. In this video, I will discuss this topic. The widely used soil classification for frost susceptibility in North America is the U.S. Corps of Engineers system. This is on page 189 from Canadian Foundation Engineering Manual. Above this table shown, there are the two paragraphs explaining the U.S. Corps of Engineers classification system. As highlighted here, this system is based on the percentage of fine fraction less than 0.02 millimeter. However, this explanation sometimes causes confusion. According to this classification system, the soils were classified into 4 classes: F1, F2, F3, F4. From F1 to F4, the susceptibility becomes more and more severe. This system mentioned in the title portion inside use a percentage finer than 0.02 millimeter by weight. However, if we look carefully this table, we'll notice that this system used actually 2 criteria instead of 1 criteria, which is the one noted here. The 0.02 millimeter criteria should be applied only to coarse-grained soils. For example, the gravel less than 3%, that's a non-frost susceptible. So that's gravel. So from 0 to 3, that's non-frost susceptible. From 3 to 10, that is F1. From 10 to 20, that's F2. And greater than 20, that's F3. So that's for gravels. So you can say when we apply this criteria, we also need to add the soil type. For sand, the same thing from 0 to 3 is a non-frost susceptible. From 3, can say 3 to 15 is F2. And greater than 15 is F3. But if the sand is fine, even though it is sand, but when it's greater, when the particles finer than 0.02 millimeter is greater than 15%, it is F4. So it can be F3. It can also be F4. Again, tells us that when we apply this criteria, we must consider the soil type. So that's for gravel and sand. So for coarse-grained soils, we use this criteria plus soil type. For fine-grained soils, we use different criteria. Let's first talk about the worst soils. Silt, wild clay. When we encounter the silt soil, automatically it is F4 class. Wild clay is interbedded clay and silt, so it's also, we can consider that's also silt. If we ignore the clay part, that's also silt soil. So when we saw silt, automatically it is F4. And then we look at clay. That is clay. That is clay. So for clay, we can see here it used the plasticity index, not the percentage finer than 0.02 millimeter. You can see here has nothing about that percentage. Also for the silt, you can see it's nothing about that percentage. So we can say fine-grained soils, silt and clay, they do not use this criteria. For silt, soil type is enough to classify it as a F4. For clay, we use a plasticity index. So PI we use PI. In this table, it mentioned one number, PI greater than 12 or less than 12. So when the plasticity index of the clay is less than 12, it is F4, or here, F4, F4C. When the plasticity index is greater than 12, it's F3C. So you can say that with the increase of plasticity, the soil becomes less frost susceptible. So there's something we need to go one step more to look at the details. This is all the data plotted on this chart. The data are from a corps of engineers testing data. You can see on this chart that the fat clay corresponding frost susceptibility of negligible to very low. It's almost similar as the clean sand. So, but this was not consistent with the table we saw earlier. According to this chart, the fat clay is supposed to be non-frost susceptible or F1. Why high plastic clay can be considered as a non-frost susceptible soil? In this video, I would not dive into it. If you want to know the answer, please watch another video I created